because the value of z decreases as we move in the negative, because the value of z increases as we move in the negative x direction and as we move in the positive z direction, we're going to consider the behavior of the z values corresponding to xy values in this quadrant of this larger rectangle. The x0, y0 point will be here. We'll move in the negative x direction. We'll move in the positive y direction. So, in the x, y, z coordinate system, we're going to let our x0, y0 be some point. The negative x direction is going to be this way. The positive y direction is going to be this way. And we expect the value of z to increase as we move this way and as we move this way. Now, just to draw a tiny diagram, then we'll draw a bigger one. So we have a z value corresponding to our x0, y0 point. As we move in this direction, we expect that our value of z will increase. Now, here's the same z values we have here. This is the point we would get if the value of z did not increase according to this motion in the y direction. It does increase, so we're going to have something that looks like this. We also increase as we move in the negative x direction, so that if we sketch a z coordinate here that's the same as the z coordinate here, we would be at this point if there was no change due to the change in the x direction. Since there is, and since it's a positive change, then the graph is going to look something like this. So in the larger picture, here's our point x0, y0, moving this distance delta x in this direction, a distance delta y in this direction. We can sketch what happens in the y direction. Let's say this is our value of z. We have an equal value over here. We would get this. The value over here is not equal. This is the positive y direction. The value of z increases, so we have some increase, and the slope of this line with respect to this direction is whatever the y derivative is. Similarly, in the x direction, if we had the same z value at this point as we do at this point, we would end up about here. And this would be our level line, the line that doesn't rise or fall with respect to the z coordinate. But since we're moving in the negative x direction and the x derivative is negative, that's going to result in an increase in the z value, and we'll have a green triangle here, let's say, that represents the change in the z value as we move in the x direction. The rise of that triangle is going to be the change in z. The rise of this triangle is going to be the change in z as we move in this direction. And if we go to this point here, we expect the same change in z due to the x, or very nearly the same change in z, because the x derivative hasn't had enough room here to change very much. And similarly, so we could pile this change on top of this change, and we could get the change that occurs between this point and this point. Now we're going to do that in a subsequent picture. Let's make sure we understand this much.